Good morning, students. Wish you all a happy Yugadi. Okay, so today we will begin with the questions on 3D geometry. Okay, so today we will discuss questions on 3D geometry. Okay, 3D geometry topic. So see, pay attention. One by one, we will try to solve the questions. Okay, so in see 3D geometry, which areas you need to focus for CET point of view. Okay, see, pay attention. 1 minute we will discuss that and then begin with our question parts. Okay, question 1 minute. So see, we will discuss this. Yes. Okay. So see, pay attention. So see, 3D chapter, it is consisting of lines and planes. Okay, lines and planes. Okay, so here in lines we have two theorems. Okay, we have two theorems, and here we have five theorems. Okay, on planes. Okay, based on planes. Okay, so these theorems, first write and take the formulas properly, because based on the theorems, one question you may expect that. Okay, then in lines, distance between skew lines. Okay, distance between skew lines. Okay, you can expect a question from here. Okay, distance between skew lines, you need to know the formula both in vector form and Cartesian form. Okay, and then angle between lines. Okay, the concept on angle between lines. Okay, same way here in case of planes. Okay, distance between a point and plane. Okay, distance between a point and plane. Angle between line and plane. Okay, angle between line and plane. Okay, so these are a few important concepts from where the questions are occurring, and other than these, you need to know the simple formulas on direction ratios. Okay, and direction cosines of a line. Okay, so direction cosines and direction cosines of a lines. Okay, so these are the concept which you need to focus, and better in one page you all write and take the formulas. After the class, you take out your board textbook, NCERT textbook, and write and take the formulas, and then once again you can solve these all questions. Okay, so we will begin with the first question. Today's first question. Yes, the first question here is the distance of the point ABC from the what x-axis is. Okay, from the x-axis. So the point P ABC is given. We need to calculate the distance from which axis? From x-axis. Okay. So now we know, if we consider any point on x-axis, its y and z coordinate will be equal to what? 0. Okay, y and z coordinate will be 0. And if we drop a perpendicular from this point, x coordinate will be equal to a only. Okay, so it's just like calculating the distance. Okay, it is just like calculating the distance between 2 points a b c, and some arbitrary point q which is lying on x-axis. It will be a 0 0. Okay, so if you calculate the distance between these 2 points, okay, if you calculate the distance between these 2 points, see, a minus a, x coordinate minus x coordinate, it will be 0. B minus c, it will be b square, and c minus 0, it will be c square. So root of b square plus c square will be the right answer. The right answer will be root of b square plus c square. Okay, understood how to solve it. Okay, so you have to just calculate the distance between these 2 points. Okay, point on x-axis and the given point P, A, B, C. Okay, A, B, C. Okay, students, off. Okay, off your mic. Mute yourself. Okay, mute yourself, students, and then attend the class. Don't disturb the class. Mute yourself and log in. Yes. So the second question, today's second question. Yes. The second question is equation of the plane perpendicular to the line. Okay, it is perpendicular to the line x by y, y by 2, z by 3, and passing through the point 2, 3, 4. Okay, so we need to calculate the equation of the plane which is perpendicular to this line and passing through the point 2, 3, 4. Okay, 2, 3, 4. Okay, so to uh, solve this, first we will consider the general form of a plane. Okay, we will consider the general form of a plane. So see, let the equation of the plane be, we are considering ax plus by plus cz plus d equal to 0. Okay, we are considering the equation of the plane be ax plus by plus cz plus d equal to 0, and then the equation of the line. Okay, equation of the line, it's given that, okay, equation of the line is already given in the question. It is given that x by 1 is equal to y by 2 is equal to z by 3. So we can write it in general form as x minus 0 upon 1, y minus 0 upon 2, and z minus 0 upon 3. Okay, so now see, both the plane and the line are perpendicular. Since equation 1 and 2 are perpendicular to each other, okay, the direction ratios, see, this direction ratios will be equal to what? Lambda. So a upon 1 will be equal to b upon 2 will be equal to c upon 3 will be equal to what? C upon 3 will be equal to lambda. So we will get it in the form of a equal to lambda, b equal to 2 lambda, and c equal to 3 lambda. Okay, these are the coordinates, these are the values of a, b, c. Okay, and see, second hint, what is given? Equation 1. Equation 1, it is passing through the point what? 2, 3, 4. So we need to replace x, y, z with a 2, 3, 4. So we get 2a plus 3b plus 4c plus d equal to 0. Okay, now see, from equation 3 and 4, from equation 3 and 4, we get, so we are replacing a with lambda, next b with 2 lambda, c with 3 lambda. So we get 12 lambda plus d, which is equal to 0. Or on simplifying, we get distance d equal to minus 20 lambda. Okay, then so d value we have obtained, and also we know a, b, c value. So on simplifying, we get lambda x plus 2 lambda y plus 3 lambda z minus 20 lambda equal to 0. Or take out lambda common and simplify it. So we get x plus 2y plus 3z is equal to 20. Okay, so x plus 2y plus 3z is equal to 20 will be the equation of the plane. So see, in this particular question, two conditions are been given. One condition is the given plane. This is the general form of the plane. Okay, this plane ax plus by plus cz plus d. Okay, see, it is satisfying two condition. One is it is perpendicular to the line. Okay, perpendicular to the line, and then second, it is passing through the point what? 3, 4. Okay, so by combining these two, we can find out the d value and as well as a, b, c value. Okay, the next question, question 3. Okay, the line x minus 2 upon 3 equal to y minus 3 upon 4 and z minus 4 upon 5 is parallel to the plane. Okay, is parallel to the plane. Okay, so see, the line is given and the plane is given. We need to identify to which given plane the line is parallel. Okay, so the which given plane the line is parallel. Okay, so here what we need to do is so the line and plane will be what? Parallel. Okay, line and plane will be parallel. Okay, if what we can say, the x, y, z value, that is the this minus 2, 3, and 4. If you substitute in x, y, z, the value must be equal towards 0. Okay, so the if the point satisfies this plane, okay, then they will be parallel to each other. Okay, so what we can do, solution part of this. Okay, so see, the equation of the plane be same again. Ax plus by plus cz plus d is equal to 0. Okay, next, the given line x minus 2 upon 3, y minus 3 upon 4 is equal to z minus 4 upon 5 is parallel to the plane 1. So see, since it is parallel, okay, we are considering their direction ratios. So 3 into a, next 4 into b, and then 5 into c must be equal to 0. See, now from the options only a plane in C satisfied the equation. Okay, so C will satisfy the equation only. Okay, C will satisfy the equation. Rest of the planes don't satisfy the equation. Okay, see the plane C when we replace, we will get see that the plane C will satisfy the equation 3a plus 4b plus 5c is equal to 0. Rest don't satisfy. So the option C will be the right answer. Okay, option C will be the right answer. Okay, next example, example number 4. Okay, so here we need to calculate the angle between the two diagonals of a cube is, the angle between the two diagonals of a cube is, okay, angle between the two diagonals of a cube is, okay. So see, we will discuss this solution. Okay, option A they are saying, okay. So see the angle between two diagonals of a cube, okay, angle between the two diagonals of a cube. So we need to consider here a cube, okay, and then we need to calculate the angle between them, okay, angle between them, okay. So as per the solutions they have given here cos inverse 1 by 3. And we'll try to discuss this example once again later we will try to discuss this. Next, pay attention. Next example, example number 5. So here, if the two lines are coplanar, if okay, the two lines are coplanar, if we need to calculate the value of what k. Okay, we need to calculate the value of what k. Equation of two lines are given. We need to check whether they are coplanar. Okay, so for coplanar, there is a condition. Okay, there is a condition. The condition is, okay, we need to subtract these. Okay, so see, pay attention. You might have come across this condition. Just I'll write it here. So for coplanar, okay, for coplanar lines, if two lines are coplanar, and then the condition is x2 minus x1, okay, y2 minus y1, and z2 minus z1, okay, divided by A1, B1, C1 and A2, B2, C2 must be equal to what? 0. Okay, must be equal to 0. So x2 minus x1, say x2 minus x1. So x1, y1, z1 is given, x2, y2, z2 is given, and the A, B, C, A1, B1, C1 and A2, B2, C2 values are also given. Okay, so by making use of this, we can easily simplify this. See, pay attention. Okay. So see here x1 1 minus 4 5 are the values of what 1 minus 4 5 are the values of x2 y2 and z2, and x1 y1 z1 the values are 2 3 and 4. Okay, so see on substituting what do we get? Okay, so see here so from 1 and 2 in that condition we are substituting, so it will be 1 minus 2. Okay, it will be 1 minus 2. So see, 1, 4 and 5 are x2. 1, 4 and 5 are x2. And similarly, x1 values are 2, 3 and 4. So 2, 3 and 4. Subtract it, you will be getting minus 1, 1, 1. Next, we know 1, 1 minus k is a1, b1, c1. And k2, 1 is a2, b2, c2. Okay, a2, b2 and c2. Okay, so here on simplifying, this we get minus 1, 1, 1. Okay, so you can expand it directly. So on expanding and simplifying, we get k into k plus 3 is equal to 0. So k is equal to 0 or k is equal to what? Minus 3. Okay, k is equal to minus 3 will be the right option. Okay, so out of the given option, option B is the right option. Okay, option B is the right option. Okay, next, next question. Okay, so the next question is let A I1 A I cap plus 2 j cap plus k cap and B I cap minus j cap plus k cap and C I cap plus j cap minus k cap a vector in the plane of A and B whose projection C is 1 by root 3 is. Okay, so see is a vector in the plane of what? A and B. It is a vector in the plane of A and B, and whose projection on C is what? 1 upon root 3. So we have to consider a vector which is present in the plane of what? A and B, and whose projection on C is equal to what they have given? 1 by root 3. Okay. So see how we can solve this. Okay. So we have to consider first vector. Okay. So see, any vector in the plane of A and B is, okay, R is equal to A plus lambda B. Okay. So this is a vector, or this is a line which is present in the plane of A and B. Okay, plane of A and B. So here we are substituting the values 1 plus lambda I cap, 2 minus lambda j cap, and 1 plus what? Lambda k cap. Okay, 1 plus lambda k cap. Okay, now see, on projection there is a formula. Okay, the projection of a vector on another vector is what? Dot product divided by mod of that vector. Okay, mod of the vector. So r dot c divided by what? Mod c. So this is equal to 1 upon root 3. Next, take the dot product with c. So 1 plus lambda into 1, 2 minus lambda into plus 1, and 1 plus lambda into minus 1. So we get these values. So 1 into 1 plus lambda, 1 plus 2 minus lambda, minus 1, 1 plus lambda, divided by root of 1 square plus 1 square minus 1 square. So on simplifying this, we get a mod of 2 minus lambda upon root 3 is equal to 1 upon root 3. Root 3 will cancel. So 2 minus lambda will be equal to plus minus 1, or lambda will be equal to 1 or 3. Okay. So on substituting the lambda value, we get R is equal to what? 2 I cap j cap plus 2 k cap, or when we substitute 3, we get 4 I cap minus j cap 4 k cap. Okay. So the option B will be the right option. Okay, option B will be the right option. Okay, next example, example number 6. Okay, so the equation of the line passing through the point 2, 3, 1 and parallel to the intersection of the planes x minus 2y minus z plus 5 equal to 0, and x plus y plus 3z is equal to what? 6. Okay, is equal to 6. So here what we need to do is, say the line is passing through 231, it's given, and it is parallel to the line of intersection of the planes. Okay, so it is passing through what? Again, it is parallel to the line of intersection of the planes. So when we try to simplify this, okay, when we try to simplify this, what do we get? See, the line of intersection we need to calculate. So 1 into 1 here we are getting, and then 2 into 1, and minus 3 into 1, that is 3. Okay, 3. So see, when we simplify this, okay, when we simplify this, we can see, see the line is passing through the point 2, 3, 1. Okay, it is passing through the point 2, 3, 1. Okay, it is passing through the point 231. So the line will be of the form what? X minus x1, y minus y1, and z minus z1. Okay, so it will be that line. Okay, and then say intersection of these two, we need to calculate the line which is passing through intersection of these two. So we need to consider the direction ratios of these lines. Okay, so out of that, out of the given equation, see, the equation A will be the right answer. Okay, equation A will be the right answer. So I'll try it again. If you don't get, again we will discuss it at the end. Next, foot of the perpendicular drawn from the origin to the plane. Okay, so we require the foot of the perpendicular. Next question, drawn from the origin to the plane. 2x minus 3y plus 4z is equal to 29. So here we need to calculate the foot of the perpendicular. Okay, foot of perpendicular. Okay, that is the point of the perpendicular drawn from what? Origin to the plane. Okay, so see, the point is given to us. Okay, the point is what? 0 comma 0 comma 0, and from there we are drawing a perpendicular on the plane. Okay, so here we need to calculate the point, okay, this point P x comma y comma z. Okay, so this is the origin and this is the perpendicular. Okay, x comma y comma z. Okay, so we need to calculate the foot of the perpendicular, that is coordinates of this point. Okay, so see how we can do this. Okay, so here first what we are doing is we are considering let okay let see, we are considering foot of the perpendicular from the point x1 y1 z1 on the plane ax plus by plus cz plus d is alpha, beta and gamma, and then we get the equation of the type, see, alpha minus x1 upon a, beta minus y1 upon b, and gamma minus z1 upon c is equal to minus ax1 plus by1 plus cz1 plus d divided by a square plus b square plus what, c square. Okay, a square plus b square plus c square. So here, see, the foot of the perpendicular, we are considering it as alpha, beta, gamma, and by using the above formula, you need to remember this formula. Okay, so coordinates of the origin are what, 0 comma 0 comma 0. So in place of x1 y1 and z1, we are replacing it by 0 0 and 0, and then on the RHS also, see, a we are replacing it by, okay, a b c d we are replacing it by the plane, and in place of x1 y1 z1 we are replacing the origin. So on simplifying this, we get, see, alpha minus 0 is alpha, beta minus 0 is beta, gamma minus 0 is gamma. So 2 minus 3 4, okay, which is equal to 29 divided by 29. So 29 upon 29, it will be equal to 1. On simplifying, we get alpha is equal to 2, beta is equal to minus 3, and lambda equal to 4. Okay, so this will be the coordinates of the perpendicular, okay, foot of the perpendicular. Okay, so 2 minus 3 4. So you need to remember this formula. The formula is alpha minus, okay, alpha minus x1 beta upon a, beta minus y1 upon b, and gamma minus z1 upon c is equal to, see, this is nothing but the equation of the plane divided by the coefficients of x1 y1 and z1, that is a square, b square, c square. Okay, so you need to substitute and simplify. Next, question number 9. Question number 9. The vector equation of the plane which is at a distance 3 upon root 4 root 14 from the origin and normal from the origin. Okay, the vector equation of the plane which is at a distance 3 upon root 4 from the origin. Okay, and the normal from the normal from the origin. Okay, so see, the distance is 3 upon root 4, and they are drawing the normal from the origin is 2 I cap plus 3 j cap plus k cap. Okay, okay, 2 I cap minus 3 j cap plus k cap is, okay. So here we need to use the normal form of the plane. Okay, normal form of the plane, we know the equation r dot n cap n will be equal to what, 0. So that equation we need to make use and simplify it. So see how we can solve it. So say distance is given 3 upon root 4, n value is given 2 I cap minus 3 j cap plus k cap. Calculate n cap. So n cap will be equal to 1 upon root 14 2 I cap minus 3 j cap plus k cap. So required equation, we know r dot n cap is equal to what, d. R dot n cap is equal to d is the normal form of the plane. So when we substitute r, at least we are considering x, y, z, and n dot n cap we have calculated 1 upon root 14 2 I cap 3 j cap and k cap. So on simplifying, root 14 d value is given 3 upon root 14, root 14 will cancel off. So the equation will be r dot 2 I cap minus 3 j cap plus k cap is equal to 3. Okay, so the option A will be the right option. Next example, example number 10. Yes. Now find the coordinates of the foot of the perpendicular drawn from the origin to the plane 5y plus 8 is equal to 0. Okay, so we have solved a similar example, example number 8. So again we are using the same type of equation. See, the equation of the plane is 5y plus 8 is equal to 0. Equation of the normal to the plane is, okay, normal to the plane is, okay, 5 upon root 25y is equal to minus 8 upon root 25, or see, this will be y equal to 8 upon 5. Okay, minus y will be equal to 8 upon 5. Okay, now the direction cosines of the normal drawn from the origin to the plane are 0, minus 1, 0, and d is equal to 8, 8 by 5 units. So here the coordinates of the foot of the perpendicular, we need to multiply this with 8 by 5. So we will get 0 minus 8 by 5 and 0. Okay, so this example is solved with little different method. So here they are asking the coordinates of the perpendicular drawn from the origin. See, either you can make use of this method, or previously we have made use of the formula. Okay, and here x and z coordinate is 0, so no need of substituting those values. So either, so this is they have made use of the formula itself. Okay, the previous formula, and they have calculated the direction cosines of the normal and then multiplied it by the distance. Okay, so the answer will be D, 0 minus 8 comma 5 comma 0. Okay, next example, example number 11. Yes, the distance of the point minus 2, 4, minus 5 from the line x plus 3 upon 3, y minus 4 upon 5, and z plus 8 upon 6 is. Okay, so we need to calculate the distance between the point and the line. Okay, distance between the point and the line. Okay, so first what we need to do is we need to calculate the points of the line. Okay, so point through which the line is passing, and then already the distance is given to another point is given. We can make use of the distance formula. Okay, so see how we can solve this example. Yes, so see, given point is a minus 2 comma 4 comma minus 5, and the line is x plus 3 upon 3, y minus 4 upon 5, z plus 8 upon 6 is equal to what? Lambda. Okay, so by equating it to lambda, we get the coordinates of the point B. How we can get it? See, x will be, see, multiply this 3 lambda. So how we can do this? See, how we can get the coordinates of the point B? Okay, so you have to get x, y, z value. Okay, any arbitrary point. So see, what we are doing is x plus 3 upon 3 is equal to what we are doing, lambda, or on simplifying, see, we get x is equal to 3 into lambda, okay, plus 3, or x will be equal to what? 3 lambda minus 3. Okay, so similarly we do it for y and z. We get 5 lambda plus 4 and 6 lambda minus 8. Okay, now see, the direction ratios of ABR, the direction ratios of the ABR, 3 lambda minus 1, 5 lambda, and 3 plus 4, 6 lambda minus what? 3. Okay, so here we are calculating, say, A and B direction ratio. So it will be x2 minus x1 comma y2 minus y1, and then comma z2 minus z1. Okay, so you have to do this. We will be getting these values, and then we have to make use of the distance formula now. Okay, distance between these 2 points. So lambda is equal to 3 by 10 vector AB. Say vector AB. So calculate the mod of that. So mod of this will be equal to 100 root 100, and then see the distance between these 2 points. Okay, distance between these 2 points will be equal to, so substitute lambda is equal to 3 by lambda in these points. So you will be getting, when you substitute 3 by lambda, we get minus 1, and then 3 by 2 and minus 6 by 5. So on using the distance formula and simplifying, we get root 37 upon 10. Okay, so root 30 upon 10 will be the right answer. That is option C. Okay, option C. Yes. The perpendicular distance of the point 6 7 8 from the plane what xy plane is. Okay, so xy plane we need to calculate the perpendicular distance. So see the point in the xy plane, z coordinate will be as it is. So the question is very simple. Okay, what we need to do, see what we need to do here. The point p is given. Okay, the point p is given and xy plane is given. So see, and this is a xy plane. Okay, this is a xy plane. So in xy plane we know, okay, the z coordinate will be equal to what? 0 in xy plane. Z coordinate will be equal to 0. So see here we require the distance between these 2 points. So if I draw the perpendicular, okay, foot of the perpendicular, if I consider it as q, so this will be 6 7 comma 0. Okay, 6 7 comma 0. Now when we apply the distance formula, 6 minus 6 it will be 0, 7 minus 7 it will be 0, 8 minus 0. Okay, 8 minus 0 will be 8 square. 8 square is 64 and square root of 64 will be 8. Okay, so 8 will be the answer. Okay, 8 will be the answer. Just off the mic and listen to the class. Students, those who are joining now, mute yourself and attend the class. Don't disturb the class. Yes. Most of you have answered it. C option. Yes. Correct. So next question number 13 now. Okay, question number 13. Yes. Is it next? Say the plane 2x minus 3y plus 7z minus 11 equal to 0 makes an angle of sine inverse alpha with x-axis. The value of alpha is equal to, okay. So the plane makes an angle with which axis they are saying? X-axis. Okay, sine inverse alpha with x-axis. The value of alpha is, we need to calculate the value of what? Alpha. Okay, so to calculate the value of alpha, so we have to make use of the formula. Okay, we have to make use of the formula. Okay, that is angle between two plane. Okay, and now when I consider x-axis, okay, x-axis, the direction cosines of that will be 1 comma 0 comma 0. Okay, direction cosines will be 1 comma 0 comma 0. See how we can do this one. Okay, see let phi be the angle made by the plane with what? X-axis. Okay, so see plane is given and x-axis direction cosines will be 1 comma 0 comma 0. So sine phi will be equal to, we need to take the product, dot product of this. So 2 into 1 minus 3 into 0 plus 6 into 0 divided by root of 4 plus 9 plus 36 into root of what? 1 plus 0 plus 0. So on simplifying, we get phi is equal to sine inverse 2 by 7. So sine inverse will be equal to alpha. So alpha value will be equal to 2 by 7. Okay, alpha value will be equal to what? 2 by 7. So 2 by 7 will be the right answer. Okay, 2 by 7 will be the right answer. Okay, next question. Question number 14. Okay, question number 14. Okay, this 14 and 15, they are out of syllabus. Okay, reflection. So this year you have not studied this. So just we will discuss the answers. See, reflection of the point alpha, beta, gamma in xy plane is, okay, reflection of the point alpha, beta, gamma in the xy plane is, in the xy plane is, we need to see xy plane z coordinate at least will be equal to 0. Okay, so only, see if you see the reflection in xy plane, only the z coordinate will change. So here see it is gamma. When you take the reflection in xy plane, it will become minus gamma. So option B will be the right answer. Next, okay, the image of 163 in the line, they are asking the image once of the line 163 in the line. Okay, even this is also out of syllabus for you. Okay, in the deleted syllabus it is. Okay, so just we will discuss this, so here you have to calculate the image. Okay, image So 1, 6, 3 is given, and here 1, 2, 3 is given. From the line we need to calculate from the line. Okay, so we'll skip this. Next, 16th one. The angle between the lines 2x plus 3y minus z and 6x minus y is equal to minus 4z is. Okay, minus 4z is. Okay, so first we need to convert this in standard form of the line. Okay, so x minus x1 upon a equal to y minus y1 upon b and z minus z1 upon c. In that particular form we need to convert this. So when we convert this in that form, we will get the values of a1, b1 and c1. So see, when we convert this, we get 3, 2 minus 6, 2 minus 12 and minus 3. So a1, b1, c1 is 3, 2 minus 6, a2, b2, c2 is 12, 2 minus 12 and minus 3. So when we multiply, angle between the lines is given by cos theta is equal to 3 into 6, 2 into minus 12, minus 6 into minus 3, divided by root of 3 square plus 2 square plus 6 square, and then root of 2 square minus 12 square plus 9. So this, on simplifying, we get it as 0. So if cos theta is equal to 0, we know angle between them is equal to what? 90 degree. Okay, angle between the lines will be equal to 90 degree. Next, the value of k such that the line lies on the plane 2x minus 4y plus z equal to 7 is. Okay, so see, the line is lying on the plane, meaning is whatever the coordinates of the point of the line are there, and they should satisfy the plane. Okay, they should satisfy the plane. So first we will calculate the coordinates of this. See, the coordinates of the point on the line are what? 4, 2 and k. Okay, 4, 2 and k, and we need to substitute this 4, 2 and k in the plane. Okay, in the plane. So see how we can solve this one. Okay, so see, first take the point. So equation 1 passes through the point what? 4, 2k, and since it line is lying on the plane, it will satisfy the equation of the plane. So in place of x, y, z, we will replace it by 4, 2 and k. So on simplifying, we get 2 into 4 plus minus 4 into 2 plus 1 into k plus minus 7 is equal to 0. Or see, 8 minus 8 plus k minus 7 is equal to 0. Or k equal to 7. Okay, k equal to 7 will be the right answer. Okay, so k equal to 7 will be the right answer. Next, the locus represented by xy plus yz equal to 0 is. Xy plus yz equal to 0 is. Okay, so we need to simplify this. So we can see that, see, when we take y common, it will be x plus z is equal to 0. So y equal to 0 or x plus z is equal to 0 will be two equations. So y equal to 0 we know is the equation of what? Xz plane. Okay, and x plus z is also an equation of the plane, and x plus z. So see, their direction ratios will be 0, 1, 0 for y equal to 0, and direction ratios of this plane will be 1, 0, 1. Okay, and when you multiply, we will get it as 0. So the angle is equal to 0, meaning is a pair perpendicular to the plane. Okay, so option D here. Okay, the option D, that is a pair of perpendicular planes. Okay, so this equation xy plus yz is equal to 0 is the equation of pair of perpendicular planes. Okay, two planes perpendicular to each other. Next, foot of the perpendicular drawn from the point 1, 3, 4 to the line 2x minus y plus z plus 3 equal to 0. Again, the same formula we have to use. Okay, what we have used there. Okay, so foot of the perpendicular, we are considering it as x1, y1, z1. Okay, drawn from the point a 1, 3, 4 to the plane what? 2x minus y plus z plus 3 equal to 0. Now see, the direction ratios of PA are x1 minus 1, y1 minus 3, z1 minus 4. So, and the direction ratios of the normal to the given plane are 2, minus 1 and 1. So equation of the line AP is given by, see, equation of this line AP will be given by x1 minus 1 upon 2, y1 minus 3 upon minus 1, and z1 minus 4 upon 1 equal to lambda. And on simplifying, we get the coordinates of this point. x1, y1 and z1. Next, on substituting this point in the equation of the plane, we will calculate the value of what lambda. So lambda will be equal to -1. So when we satisfy, when we substitute 2 into minus lambda, then 3 minus lambda, and z1 is equal to lambda plus 4. So in this points, if we substitute lambda value, we will get the coordinates of the point P are -1, 4, 3. Okay, so -1, 4, 3 will be the coordinates of the foot of the perpendicular. Okay, next, acute angle between a line and the plane is, okay, so line and the plane, we know the formula for acute angle. Okay, to calculate the angle between what line and the plane, we have a formula. The formula is what sine theta is equal to, okay, sine theta is equal to b dot n divided by mod b mod n. Okay, mod b mod n, where b is the vector, parallel vector to the line, and n is the direction ratios of the plane. Okay, normal to the plane. So see here what we are doing, direction ratios of the given line are 2, -1, 1, and direction ratios of the normal to the given plane are 3, -4 and -1. So we have to apply the formula. Sine theta is equal to multiply both. 2 into 3 it will be 6, -1 into 4 it will be +4, and 1 into -1 it is -1. Root of 2 square is 4, 1 plus 1, and then root of 3 -4 and -1. So on simplifying, we get 9 upon root 6 root 26, which is equal to 9 upon root 156. On simplifying, we get theta is equal to sine inverse 9 upon root 156, or sine, when we convert it in terms of cos inverse, it will be root 75 upon 156, or on simplifying we get 75, we are simplifying it, and then 56 also we are simplifying it. So 75 can be written as 25 into 3. Okay, and then 156 we need to simplify it. So on simplifying, we get 5 upon 2 root 13. Okay, that is option B will be the right. Next, the distance of the point 1 to 1 from the line x minus 1 upon 2 equal to y minus 2 upon 1 equal to z minus 3 upon 2 is. So we have to calculate the distance between the point and what this line. So first we have to calculate the coordinates of this line. So the coordinates of the line, point q on the line are what, 2r plus 1. Okay, r plus 2, 2r plus 3, and then we need to see the coordinates of the point are 1 to 1. Okay, so we have to apply the perpendicular to the given line is what, r is equal to, since perpendicular it will be -4/9. So we will get the coordinates of the point q, and once we get the coordinates of the point q, we can make use of the distance formula. So by applying the distance formula, we get 2 root 5 upon what, 3. Okay, 2 root 5 upon 3 will be the final answer. Next, xy plane divides the given line joining the points a 2, 3, -5, and b -1, -2, -3 in the ratio. Okay, in the ratio. So this we can do it directly. So here what we can do is, see, the xy plane divides the line joining the points a and b in the ratio k is to 1. We have to consider. Apply the section formula for internal division. Okay, so when we apply the formula, we get k into -1 and 1 into 2. So we will get minus k plus 2 upon k plus 1. Similarly, k into -2 and then 1 into 3, we will get -2k plus 3. And similarly, on simplifying, we get -3 into 1 and -5 into what? -3 into k and -5 into 1. Okay, so it will be -5. So this is the equation. Now see, since the plane is xz plane, its z coordinate will be equal to 0. So whatever the z coordinate is there, you equate it to 0. On simplifying, we get k equal to -5/3. Okay, so -5/3 is the right answer. Okay, so this has occurred from first year part. Okay, not from the second year part. So in the first year part, there is introduction to 3D. So from there, this question has occurred. Next, the sine of the angle between the uh, line and the plane is. Okay, so just now we discussed sine theta is equal to, so the same formula we have to apply and simplify. Sine theta is equal to a1 a2 plus b1 b2 c1 c2. So on substituting and simplifying, we get 2 upon what, root 2 upon 10. Next, if a line makes an angle pi by 3 with x-axis and y-axis, then the acute angle made by z-axis is, okay, then the acute angle made by what, z-axis is, okay. So here what we can do, see, so first we have to consider, let the angle made by what, with x-axis and y-axis as alpha and beta. We have to use the formula of direction cosines. L square plus m square plus n square is equal to n. So these two, at least cos pi by 3, we know it is 1 by 2. Cos pi by 3, it is 1 by 2. Cos square gamma, keep it as it is. So 1 by 2 plus 1 by 2, it will be 1 by 4. 1 by 4 plus 1 by 4, it is 1 by 2. 1 minus 1 by 2, it will be again 1 by 2. Or cos gamma will be equal to plus minus 1 upon root 2. On simplifying, we get gamma is equal to pi by 4. Okay, so gamma is equal to pi by 4 is the angle made by the line with z axis. Okay, with z axis. Okay, next, another few examples we will discuss. Another two examples and then wind it up. So here the next example is the distance of the point 1 to minus 4 from the line. So from the line, so again we have to same, we have to calculate the coordinates of the line. So by making use of the coordinates of the line, we have to find out the value of what, lambda, as we have done. So lambda we have got minus 1 by 49. So by substituting, we will get the point P, which is lying on the line, and one more point is already given. Make use of the distance formula, so we will get the answer as root 293 upon 7. So we have solved the same example we need to do. Okay, and then the last question, see, the point 1 minus 3 4 lies on the octant. Okay, 1 minus 3 and 4 lies on the octant. So this also has come from the first year part. Okay, so see, 1 minus 3 4. So simple, we need to know the octants here. So see, in the octants, in the given octants, we know. Okay, 1 minute, see, pay attention. So okay, so we have see the first octant, first, second, and what, third, fourth. Okay, so see, these will be, see, plus and what, plus. So when we consider z as positive, so see, this will be z axis, so it is in positive direction, and then we consider it is in negative direction, so this will be negative. This will be positive. Height will be positive, depth will be negative. So see, this will be again minus, plus, and minus, plus, and plus. Okay, so see, this is minus, minus, and plus. Okay, and this will be plus, minus, and plus. See which of these octant. See, 1 minus 4, 1, 2 plus signs, and 1 negative sign. So it will lie in which octant? Fourth octant. Okay, so answer B will be the right option. Okay, so we have discussed a few examples. I think around about 25 examples we have discussed on 3D. So again, some more are there in the PDF. Okay, you can go through the PDF. Okay. So today we will stop here. Okay. Again, some more examples we will continue. We will continue tomorrow. Okay. I think another 20 examples are there. So that we will try to discuss in the tomorrow session. So we have two sessions for 3D. So I think till question number 26 we have covered now. So remaining questions we will discuss it tomorrow. Okay, then we will meet tomorrow, and take care. Bye.